simplifying algebraic expressions. This is going to be something that you're going to build on farther and farther that you go in your math career. Today we're just going to look at the basics of it. Think about simplifying something. You're making it smaller. Usually you're making it where it makes more sense, and that's what we're looking for simplifying algebraic expressions. First, let's take a look at the parts of an expression. So the expression we're examining is 7x plus 4. Three important parts to this. First, the 7. This is what we call the coefficient. It tells how many of the variable. So 7x literally means x plus x plus x plus x plus x plus x plus x. 7 is being multiplied by x, and as you know from 3rd grade, multiplication shows repeated addition. X is being added 7 times. Think of it as like the co-worker with the variable. This could be a positive or it could be a negative. The next is the x, the variable, and you're familiar with a variable. It represents an unknown value. It could be x, it could be y, it could be w, it could be all kinds of different letters. And then the 4. This is what we call a constant. A constant is a number without a variable. It's constant because its value always changes. 4 is always going to be 4, whereas something like 7x, that could change because depending on what x is, the value of 7 is affected then. And then know that these are called terms. Terms are separated by an addition or a subtraction sign. So we can see two terms in this expression. 7x is a term and 4 is a term. Now that we know what a term is, we're going to look at like terms. Like terms have the same variable to the same power, talking about exponents. I've grouped some families that have like terms. So in purple you see the x family. 7x would be a term. Negative 4x. X. When you see a variable by itself like this, that simply means 1x. It's like there's an invisible coefficient there. In blue we have constants. Negative 12, 44, 100. In red, this is the y squared family, 4.5 y squared, negative y squared, and that negative in front of it is like there's a negative 1 as a coefficient, and 6y squared. In green is the xy family. We've taken the x's and we have the y's, but xy is different. They're different variables. So xy would be a term, 4xy, negative xy would also be a term. Let's look at combining like terms. This is one of the major two ways that you're going to see how to simplify algebraic expressions. One is combining like terms. When you're combining things, you're adding them, just like you learned yesterday in translating algebraic expressions. When you combine things, you're adding them together. So first step is to identify the like terms. I like to draw shapes around my like terms. So I'm going to start with 7x. I'm going to put a circle around 7x. And I'll look through the rest of my expression for terms that also have an x in it. Negative 4 is a term. What you're going to start seeing is that negative 4 is a term, not necessarily 4, but look at the sign to the left of it. I can call that negative 4 instead of subtracting 4 because as you learned in integers, to subtract 4 is the same thing as adding a negative 4. If you want to go through and do keep change on all the subtraction signs, you can definitely do that. It's not necessary. You want to train your brain that when you see a subtraction sign, you automatically think of that term as being negative. So continuing on, looking for terms that have an x in it. Negative 4 is not like it. However, positive 2x is. And then my terms that are left over, I have negative 4. I'm going to put a square around it and a square around positive 5. So we've identified our like terms. Second, we're either going to add or subtract their coefficients. They're either being added or subtracted depending on if that term was positive or negative. Like we were saying, that was a negative 4. So let's add the coefficients. Let's first go with 7x and 2x. You add them, so that would be like saying 7 plus 2x, which is 9x. And then let's look at the negative 4 and the positive 4. That's like I have negative 4 plus 5. And negative 4 plus 5 is positive 1. And that is simplified. 9x plus 4. I do not expect you to write out this step right here. where I have all those parentheses and it looks kind of lengthy, that is supposed to be happening in your head. I just wrote it out so you could kind of see how it is that we got 9x and how we got 1. Something students struggle with is they see 9x plus 1 and they feel like they should do something else with it, that they need to combine it and make it 10, but you can't do that because 9x and 1 are not like terms. 1 does not have a variable, it's a constant. I can't combine it with 9x. That's as far as it goes. Another way that you are going to simplify these expressions is using the distributive property. Remember that from the last unit. It means that when you see a number against the parentheses, you're going to distribute that number to each term inside. You're going to multiply it. So I'm going to take negative 3 and I'm going to multiply it by each term, by x and by 7. Negative 3 times x is negative 3x. And then I'm going to do negative 3 times 7. Copy down the rest of it. So negative 3x comes down. Negative 3 times 7 is a negative 21. So you can either write that as plus a negative 21 or as minus 21. Plus 3x. Now I'm going to do what we learned in the last slide. We're going to combine like terms. Negative 3x is like positive 3x. To combine those like terms, you add their coefficients. So in my head, I add negative 3 and positive 3, and I get 0. So I would write 0x and then bring down negative 21. That looks weird, and it should. You actually wouldn't even have to write that because we know, because of the zero property, that that 0 times anything is just 0. So these actually cancel out, and all that I'm left with is negative 21. One of the rare occasions that your final answer is just a number and there's not any other variables in there. Here's some practice problems. You go ahead and try those and then we'll compare. Okay, on practice A, you can see where I boxed my like terms with a different shape for each term family. I started with x to the third. I have 5x to the third and 7x to the third. Notice how I'm boxing the sign that's to the left of the term. That way I don't leave off any negatives if there are any. 5 plus 7 is 12, so that's where 12x to the third comes from. Then when I went on looking for like terms, I have a positive 3y and a negative 2y. You'll see that I haven't boxed anything with negative 4x squared because he doesn't have any family members. He's all lonely and by himself. If you wanted to put a different shape, if you wanted to put a heart or a triangle around him, you definitely could. But he doesn't have any like terms, so he's just going to be brought down. Now, I brought him down next because the math grammar kind of proper way to do this is to go alphabetically. So x comes before y, and your powers are in descending order. So the third power and then the second power. I took the negative with negative 4x squared. It comes down and it becomes subtracting 4x squared. I combined my y's, positive 3 and negative 2. They combine to be a positive 1. And we leave that coefficient off because we want things to be as small as possible, as simplified as possible, and it's just y. So that's your simplified form. 12x to the third minus 4x squared plus y. If you had these out of order, for instance, if you had 12x to the third plus y minus 4x squared, that is an equivalent expression, because what I've done is I've still kept that negative attached to the 4x squared, and I've brought it over here in front of it. So that would be another way that would completely be correct. It's just not in the same grammatical order. If you really like for your answers to match an answer key perfectly, you're going to want to put it in the correct order. Otherwise, this is fine. It means the same thing. I'm okay with this. Part B, we have to use the distributive property. That 2 is distributed to each term inside the parentheses. 2 times a is 2a plus 2 times a squared is 2a squared. And I have this 2b over here on the side. Your next step would be to look for like terms, but there are not any like terms. So it would just stay as is. Part C, to find the perimeter. We know from elementary school, to find perimeter, you add all the sides together. This looks a little different from most perimeter problems that you're used to. The same principle applies. We're going to add all the sides. You can see here where I listed all the sides, n plus 2, plus n, plus n, plus n. And I counted my n's, to double check, because sometimes you can make an error with that. I'm going to combine my like terms. All of my n's are going to come together. I have 1, 2, 3, 4 n's. So that becomes 4n, and the 2 comes down. He doesn't have any else in his like term family. So the simplified form is 4n plus 2.